Hi everyone, welcome back to Bonbon Science. Today we will be going over Unit 1, Topic 7 in AP Chemistry called Periodic Trends. This one's big, so let's just get straight into it. So periodic trends are these patterns that we notice in certain atomic properties, and there are 5 that you need to know for the AP. And they are atomic radius, ionic radius, electronegativity, electron affinity, and ionization energy. So let's go over those one by one. So first, we're going to cover atomic radius. And so as the name would imply, this is literally the radius of an atom, or literally just the size of an atom, basically. And the trend for this one is that it increases as you go down, and it increases as you go to the left. So, for example, fluorine is smaller than oxygen, lithium is smaller than sodium, and so on and so forth, right? So like one of our biggest elements is like francium, for example. Now, for the AP, you need to do more than just memorize this. You also need to understand why this trend is the way it is. This is important for multiple choice questions and some free response questions. And so for pretty much every periodic trend, you can just think of things in terms of Coulombic force and Coulomb's law. So the reason it increases as you go, well, I'm going to start with as you go down. The reason it increases as you go down is because of something called the shielding effect. So as you add energy levels, the atoms get larger, right? And that's just a general fact. As you add energy levels, atoms get larger, and this is because of the shielding effect. And this actually has nothing to do with Coulomb's law. But the shielding effect is basically when you are on higher energy levels, there are electrons on lower energy levels. So the electrons on the higher energy levels get shielded by the electrons at the lower energy levels, because we all know that like repels like. If you've ever held two negative sides of a magnet together, they repel each other. It's the same thing here. The negative electrons repel each other, and so the electrons aren't attracted as strongly by the protons in the nucleus anymore. And so they're kind of farther out because they're not held as well together. So it actually does decrease the Coulombic force, but because of something we call the shielding effect, and so the electrons go farther out. So as you add energy levels, atoms get larger. So that's why an atom on the 7th energy level is way larger than one on the 6th energy level, because you're on an extra energy level, right? The reason it increases as you go left is because you have less protons at the same energy level. So since you're at the same energy level, shielding is the same. But since you have less protons, there's less Coulombic attraction, right? We know that Coulombic force is proportional to charge. So if charge gets lower, then the Coulombic force gets lower. So Coulombic attraction is lower, so the electrons aren't held as tightly anymore. So the atom gets larger because the electrons are more loosely held and they go farther away. So that's atomic radius. Okay, cool. Now let's talk about ionic radius. And for this one, you don't really need to know a trend. You just need to know a couple of things. First, if you don't know what an ion is, it's when an atom has a different number of electrons than protons. So like oxygen has 8 protons. If it has 8 electrons, it's not an atom, it's not an ion. But if it has anything that's not 8 electrons, then it is an ion. And cations and anions are 2 types of ions. Cations are when an atom loses an electron or electrons, and anions the opposite. It's when it gains an electron or multiple electrons. And the general thing you need to know is that cations are usually smaller and anions are usually larger. And this is because cations lose electrons, so they usually lose entire energy levels and become a lot smaller, right? Like I just explained, a lot less shielding, it becomes a lot smaller. Meanwhile, anions, they add electrons, and the extra electrons repel each other. So a little bit more shielding, and so the atom grows larger. Now, you also need to be able to compare isoelectric species. And isoelectric species are when you have 2 atoms with the same amount of electrons. So for example, let's take O2 minus and F minus. So you'll notice that oxygen would usually have 8 electrons, but 2 minus means it gets 2 electrons. So that would put it as 10 electrons. And F minus, F usually has 9 electrons, but if you add 1, then we're at 10 electrons. So these are isoelectric species. That's the term. When you're comparing isoelectric species, which the AP usually makes you do, first just check if they're isoelectric, right? Just check your periodic table, make sure. When they're isoelectric, the one with less protons is the larger one. and the one with more protons is the smaller one. So oxygen has 8 protons, fluorine has 9, so oxygen is our larger one, and fluorine is our smaller one. And this is literally just Coulomb's law, right? Because oxygen has less protons, there's less Coulombic attraction, so the electrons aren't held as tightly, so they're farther away, and fluorine is the exact opposite. More protons, more Coulombic attraction, electrons are held more tightly, so the atom is smaller. And that's all you need to know for ionic radius, really. Now let's discuss electronegativity. And electronegativity is the ability of an atom to attract electrons to itself in a bond. So bonds, we haven't covered that yet, but bonds are when two atoms or multiple atoms kind of like interact with each other in a way. And they usually interact with each other by sharing electrons or giving each other electrons. Electronegativity measures how well an atom can attract electrons to itself. So the trend for this one is the exact opposite as the one for size. So it actually increases as you go up, and it increases as you go to the right. And this makes sense, because if you think about it, for an atom to attract electrons to itself, it needs to have a higher Coulombic force on those electrons to pull them in better, right? So smaller atoms have a smaller radius. Because they have a smaller radius, they're able to pull electrons way easier because there's a much higher Coulombic force, right? Coulombic force and radius are inversely proportional. And so that's why that trend is the way that it is, and just makes perfect sense, right? But there is one big exception to this, and that's your noble gases. And your noble gases are this rightmost column. Sorry, that's not a great box, but just imagine it's the rightmost column here that I've kind of tried to box in. The reason these are an exception is because they don't have electronegativity. And that's because noble gases don't form bonds, and we're going to talk about why this is. But for now, you just know that noble gases don't form bonds, and so because they don't really form bonds, you don't see them have an electronegativity value. So we just say they don't have electronegativity, so they're kind of excluded from this. And just a piece of information you should know, fluorine is the most electronegative element, because it's the furthest to the right and it's the furthest up, but it's not a noble gas, right? So it's not helium, because that's a noble gas, it's fluorine. Next, we're going to discuss electron affinity. Now, this one's a weird one. Haven't seen it tested too much, and I've never seen them ask about the trend, because the trend is really weird, and it has a lot of exceptions. So I wouldn't even worry about it. But you do need to know what electron affinity is. So electron affinity is the energy released by an atom when an electron is added to it. And it's a gaseous atom. It has to be a gaseous atom, which just means an atom that's a gas. And while you don't need to know the trend, it is helpful to know the equation. And so the equation would be any gaseous atom, so let's just do sodium. So Na gas plus E minus. E minus is the symbol of an electron right here. And so since we added an electron, you get Na minus, right? Because it's becoming more negative. It becomes negative by 1 electron. So Na minus gas. This is electron affinity. This is all you need to know. Don't bother memorizing the trend. Just know this equation and you'll be golden. But remember, this can be any atom. This could be sulfur, oxygen, whatever, right? Awesome. So now we're on to the last one, ionization energy. And this is the energy it takes to remove the outermost electron from a gaseous atom. So this is gaseous again. And it's outermost electron. Keep that in mind. It's not just any electron, it's the outermost electron. So the equation for this is the exact opposite. So we'll have Na gas becomes Na plus, because we're removing an electron, so it becomes more positive. Na plus gas plus E minus. And this is what we call the first ionization energy, because you're pulling out the first electron. There's also the second ionization energy, where you pull out the second outermost, and the third, where you pull out the third outermost. It's just the same thing, but the charge is different. So like second ionization energy would be Na plus becomes Na2 plus E minus, because you pulled out an extra electron, so it goes from plus to 2 plus. And the trend for this one is actually the exact same as electronegativity, and this time the noble gases aren't an exception, so they're also part of the trend. So they do have a very high ionization energy because they're furthest to the right. And this also makes sense if you think about it, because once again, think about size. As you go farther up and to the right, your atoms get smaller and smaller. And when they're smaller, you have higher Coulombic attraction because your distance goes down. And because your distance goes down and your Coulombic attraction is higher, it's going to be harder to pull those electrons out, right? It's going to take a lot more energy for you to remove those. And so that's why your ionization energy has this trend. So just know that justification and know this trend, right? And so a quick recap, ionization energy and electronegativity increase as you go up and to the right. Atomic radius increases as you go down and to the left. Now for ionization energy, there are a couple of exceptions you need to know. But first, usually the second ionization energy is greater than the first ionization energy. And the reason this is because when you pull out an electron, there's now less electrons, obviously, right? Which means there's less shielding. There's less electrons repelling each other, so it's going to be a little harder to pull out the next one because there's not so much shielding, so it's going to be a little harder to pull out. And the next one's going to be a little harder, and the next one's going to be a little harder because there's less electrons shielding each other. Now, the exceptions that you need to know are that first of all, there's a jump, or actually, ionization energy decreases when you go from P3 to P4. So let's take a look at the periodic table. So nitrogen and oxygen, that's P3 to P4. So oxygen is to the right of nitrogen, so it should have a higher ionization energy, but it's actually a little lower. And that's because subshells have these things called orbitals, and we talked about this in the electron configuration episode. They have orbitals, and orbitals can hold 2 electrons. And orbitals don't double up unless they have to. So boron fills up one p orbital, carbon fills up a different p orbital, and nitrogen fills up the third p orbital. At oxygen, there's no fourth p orbital, so that fourth electron is forced to double up with another orbital. And when it does this, because these electrons have doubled up, there's a little bit of shielding going on, and that makes it actually easier to pull out that p4 electron, just because of that shielding and that repulsion. And so you see a little dip in the ionization energy. But then the trend goes back to normal. So fluorine is more ionization energy than oxygen. But you'll see this little dip when you go from P3 to P4. So just keep that in mind because they do ask about that sometimes. And the other thing you need to know is that there is a big jump when you're going down in energy level or when you're going down a subshell. So if you're going down a subshell or if you're going down in energy level, you see a massive jump, and that's just because of radius. When you go down a subshell, the S subshell is a lot closer to the nucleus than the P subshell, so you see a big increase in ionization energy. And when you go down in energy level, it's also a lot closer to the nucleus, so you see a massive increase in ionization energy. So these are just 2 things you need to keep in mind. Because S is a little closer than P, and because the first energy level is closer than the second, and the second is closer than the third, whenever you're jumping down a subshell, or whenever you're jumping down an energy level, you will see a massive spike in ionization energy. But that's all you need to know for periodic trends. I know that was a lot, I know it was a mouthful, but just make sure you know the reasoning behind the periodic trends and make sure you're understanding them, and you'll be golden for the AP exam. I hope you enjoyed the video. Please like and subscribe if you did, and I hope you found this helpful. Thank you.